Today's lesson is on rates. Now, rates are like ratios. They're a little bit different, but to get started, we're going to try something different. Get a pencil and paper, and we're going to see how many triangles you can draw in 1 minute. We'll make it a little competition, and you guys can tell me later how many you could draw in 1 minute. I'm going to start my timer, and I'm going to actually time it for 1 minute. So, competition. How many triangles can you draw in 1 minute? Go. Now, I'm going to cheat a little bit and use the triangle maker, but you're drawing it with paper and pencil. You can probably go faster, maybe, I don't know, but I'm just going to keep going, and you're going to keep going until a minute is up. Maybe you can beat my count of triangles. I have my timer on. We have 20 seconds left, so keep going. They don't have to be the same kind of triangle, just as long as it's a triangle. Okay, time's up. How many triangles did you draw? You count yours and I will count mine. Okay, I think I got 53. So, how many did you get? You can tell me when we meet again how many triangles you were able to draw in a minute. But what was the purpose of this thing? Well, if you know how many triangles you can draw in 1 minute, could you figure out how many triangles you could draw in 2 minutes? If I could draw 53 triangles in 1 minute, how many could I draw in 2 minutes? Well, 53 the first minute plus 53 the second minute. How many triangles would that be? 106. How many triangles could I draw in 3 minutes? Well, let's add another 53 onto it. Let's see how many I could draw in 3 minutes. 159. So rates come in handy sometimes when we're trying to figure out how long it will take to do something. So let's go on. When we mention a rate, we would say 53 triangles per minute. And this is the way we would write it, with a slash and just the word min. 53, that's not a zero, that's a triangle. So 53 triangles per minute. Per means for every or in every. So this would read 53 triangles for every minute, or 53 triangles in every minute. And here are some rates. Let's do our little sample. A tortoise travels 0.2 kilometers per hour. The popcorn machine makes 8 bags of popcorn per minute. So one way we can figure things out is to make a little table. How many kilometers does he travel per hour? So 0.2 in the first hour. So how many would it be after 2 hours? 0.4 after 2 hours. How many would it be after 3 hours? 0.6. So you notice that it's increasing by 2 every time. What about the popcorn machine? It makes 8 bags of popcorn per minute. So in 1 minute, it makes 8 bags. How many would it make in 2 minutes? 16. So this is going to come in handy when you're trying to figure out how long it will take to do something. Notice down here, a rate is a ratio. It's a ratio, but it compares 2 items measured in different units. The speed of the tortoise compares a distance in kilometers, this here, to a time in hours. So it's comparing two different things. And there's a few different ways to solve ratio and rate problems. With the ratios, these charts, these tables worked very well. But with a rate, there's three different ways that we could do it. We're going to look at three different ways. So the first way would be just to draw a picture. So we have here, Juan typed 9 pages in 3 hours. At this rate, how many pages could Juan type in 5 hours? Well, this doesn't work as well with a table, and I'll show you why. So 9 pages in 3 hours. And I want to know how many in 5 hours. The problem with just doing a table is that we can't multiply 3 by something to get 5. So that's not going to work for us at this point. One way we could do it is draw it. Here's the 9 pages, and this represents 3 hours of work. So how many pages did he do in 1 hour? 3. So that tells us something. If we know 1 hour, he did 3 pages, could we now figure out how many it would be in 5 hours? Well, from 1 to 5, we multiplied it by 5. I'm not good at writing with the mouse yet. And so we would multiply the 3 times 5 as well, and we would get 15 pages in 5 hours. We could have just reduced this to simplest terms. If we wanted to, we could have said, okay, 9 pages in 3 hours, how many would that be in 1 hour? And if we reduced it to simplest terms, we would have gotten this as well, because they're both divisible by 3, and you would have gotten 3 to 1. I guess in a question like this, it's important to try and figure out how many he does in 1 hour, so then you can figure out how many he would do in 5 hours. Okay, the next thing you could do is use a graph. And some of the questions you're going to be doing today, you will need to use a graph. So if you don't have any grid paper at home, you might want to print it off of the internet. Just do a Google search for grid paper or graph paper, and then print a page for yourself. So in this one, we are going to read this word problem. A killer whale travels at an average speed of 50 kilometers per hour. How far does it travel in 5 hours? So if we're making a graph, we would put obviously time across the bottom on the x-axis, because time usually goes on the x. The distance in kilometers here. So how far does it travel in 5 hours? So let me just put our dots in here. So after 1 hour, it has traveled 50 kilometers. After 2 hours, it's traveled 100, because we're going up by 50 every time. After 3 hours, and after 4 hours. So we could continue like this, and we could figure out, we wouldn't have to keep going. We could figure out just by connecting these dots, and I'll show you how far he went in 8 hours. So if I keep going with this line and I connect the dots, now it's not working. Oh, did I put that in the wrong place? Yes, I did. Okay, sorry about that. So if I continue this line, I could figure out, there's my mistake here. Sorry about that. I put the dot in the wrong place. Let me just fix that. And it would be here at the 250 would be the dot. So looking at this, we can now use the graph to figure out how far they would have gone at 7 hours by just going up here and finding out where it lands. And it lands at the 350. So we could see 7 hours, it would be 350. So that's another way we can figure out rates. So the first one was draw a picture. The second one was use a graph. And the third one is use a table. I found this kind of funny because the example they used in the book tells how old the book is because it's talking about paying per minute to make a long distance phone call. Now, I remember the days when we used to have to pay per minute, but I don't think you guys do. It used to be that if you made a long distance phone call, you had to pay per minute. And so you didn't spend a lot of time on the phone because you were trying to save your parents money. All right, so use a table. Ainsley paid 95 cents a minute, 95 cents per minute, I should say, to make a long distance phone call to her aunt in Scotland. Ainsley's bill was $7.60. How long did they talk? Well, we don't know the answer to that yet, but we know that for 1 minute, it costs 95 cents. How much would it cost for 2 minutes? Well, you'll have to add 95 plus 95, and you're going to get $1.90. What about 3 minutes? Add on another 95 cents, and you're going to get $2.85. 4 minutes. Add on another 95 cents, and you're going to get $3.80. Are we there yet? Nope. Her bill was $7.60, so we have to keep going. Add on another 95 cents, and you get $4.75. Okay, after 6 minutes, it would be $5.70. Are we there yet? No. So we have to extend this table even further. After 7 minutes, it would be $6.65. Not quite there. And after 8 minutes, it would be $7.60. So you can see here that we had to extend our table a little bit, and we found out how long did they talk? Well, we know that it was $7.60, so we can look here and see that they must have spoken on the phone for 8 minutes. Hopefully this was helpful. If you have any questions or problems with any of this, you can come to our meeting at 11 o'clock and we will discuss